control. I need to try to find a way to not be so loud. All right, so guys, the thing I forgot to talk about on Monday, and these notes are going to look a little bit different than yours because they're from the other class. I felt like I took them a bit neater. But guys, you should always be picking up where your notes left off. Each class day of notes should not be new paper. So guys, when we're back in school, I'm going to be checking things like that. Like, hey, are you continuing the notes that we took on Monday? Because that's what we should be doing. So one thing I wanted to make sure that I reminded you of is this little list about proportional quantities or proportional relationships. Ours was kind of messy on Monday, and that's probably my fault. It is my fault. But please make sure that you have in there that when we talked about the cupcakes, 0, 0 would have been a point that we had, right? 0 cupcakes would cost $0. The constant of proportionality, which all proportional situations have, is how you get from the x to the y, right? In our case, this was c to d, but it's how you get from the x to the y, so that is times 2. And then we talked about if you multiply or divide on the left or right side, the same thing happens, right? So I got to pull my zoom back a little bit. But if I double the amount of cupcakes, I double the amount of money. If I triple the amount of cupcakes, I triple the amount of money. So even though these numbers are not the constant of proportionality, it's what happens in all situations that are direct variation. So then in dealing with, I forget what their name was. Did we have the E equals 10H equation? I don't think so. Or maybe?
Yeah, we did.
Okay. Making sure that we have all those notes. And did we talk about Jackson? That's what I thought.
We did.
So I think this is where we left off with euros and dollars. Has anyone traveled to a country where they use euros? Miriam, can you tell us what a euro is?
Well, it's the currency, and I can't remember where it was I went. I think it was it Italy? I can't remember.
Probably, I would think.
We went on a cruise where we went to a bunch of places in the Mediterranean, and it was fun, and we got to stop at a bunch of places.
That's awesome. I love cruises. So the euro is very similar to the dollar, and we're going to come back to that in just a second. But what I wanted to remind you guys is this should be in your notes from last week, where we talk about the reciprocal values. So I had to pull my other sheet of notes out, so that's why I wanted Miriam to talk about euros for a second. But when we talk about these two values, these are both unit rates. So guys, I don't think we wrote this down on Monday, so you should, in your notes, write down that these are both unit rates, and they're reciprocals of each other. Because one is kilometers per liter, and the other is liters per kilometer. This same situation is going to happen for our conversion between euros and dollars. So, check out this situation. I'm going to throw you into breakout rooms really quick so you can chat for like a minute. And guys, here's what I want to say about breakout rooms. Don't come back when it says like, hey, you have 1 minute left. Don't come back if you still have more to say, because we're gonna wait for that minute to go up, and at the end of that minute, it'll pull you back automatically. So if you guys are still talking, stay in your breakout room. But just like before, if you need to pull up Schoology, pull up Schoology. But what we're asking is how many euros is equal to $1, and how many dollars is equal to 1 euro? These are the two exchange rates, but there also are two unit rates. So let's, if I can get my Zoom controls to work. Real quick. I want to do smaller breakout rooms so they're easier to talk. All right, hop into your breakout rooms and chat about what you think the two different unit rates or exchange rates are here. You think you guys got it figured out, Stella?
I didn't mean to come back.
You what? You didn't mean to come back? Well, I hit the thing to bring you guys back in the next minute.
I tried to hit the X.
Ah. To stay there?
Screen and my binder's covering the mouse. So I went like that and I hit the
Alright, so if we talk about both unit rates here, it's actually the exchange rates of if you were to go to like Italy or any of those European countries, which we'll be able to again soon enough. So if we write down this formula, this equation, euros equals 17 over 20 times dollars. Please make sure you have this in your notes. So then, what does that mean? Anyone want to talk to like what the exchange is? Can anyone tell me which is stronger, the dollar or the euro? Like what does $1, question A here, what does $1 get you? How much? I think Jocelyn got kicked out of the call. Martin, what do you guys think? I'm just looking randomly at my screen. Remember, you guys can always pass. But what'd your group say? For part A, what does $1 get you? More than a euro or less than a euro? I don't know if Martin heard me say his name. Drew, was that a hand? I can't tell in the shadows. Stella, what do you think?
less than a euro.
It's less than a euro, right? Because if I plug $1, one US dollar, right, gets the dollar sign. If I plug in $1, our answer is 17/20ths, which is less than 1. So guys, $1 US would get you less than a whole euro. If you want to think about it like cents, but it doesn't work like this. But it's 0.85 euros actually. So 17/20ths as a decimal is 0.85. For part B, it's the other way around. How much would 1 euro, one whole euro, well then that would be more than a whole, right? So if we plug in the other way around, our other unit rate, again, is the reciprocal. Our two unit rates, when we reverse the order of what we're asking, it says how many US dollars have the same value as 1 euro. It takes more than a US dollar. It takes about $1.17, actually $1.18. So we should go ahead and write it like that. Where's my purple pen? So guys, what that means is our money is weak. The US dollar is not a very strong currency because it takes more than $1 of our money to kind of equal like $1 of their money, right? 1 euro, if I plug in 1 euro here, and we talked about this fraction problem solving before, please write it down and then I'll make sure we understand the process. 1 euro equals $1.17. Can I go back up? Absolutely. Here, I'll even pull this zoom up a bit. So guys, we're pretty close to moving on from these sort of problems. So please use chat to tell me if this stuff doesn't make sense to you. These are both unit rates. Actually, I might put this in a little bright note. So what we're saying is, the two unit rates are reciprocals. So 17/20ths. I'm going to split my paper here. I'm going to double check this while you guys are writing. That's what it is. Guys, that's the symbol for a euro. 1 euro equals, what did we say, $1.18? But really what that number is 20/17. That just doesn't make sense to you guys when it comes to money, probably. So 20/17 versus $1 was 17/20ths, or 0.85. They're reciprocals of each other. Alright, I don't know about you guys, but I'm bored. It's real quiet. And yeah, I can't wait to be back at school. But let's change pace. We've been doing these sort of problems for a while. If this still doesn't make sense, please come to AO or Extensions today to talk to me about this stuff. Let's talk about graphs. So, Jameson collects eggs from his chickens every day. And I've heard that people in Worthington have chickens, but I can't believe that that's allowed in a town like Worthington. But chickens are sweet. They lay eggs. And depending on the type of chicken, depends on how many eggs you're going to get per chicken. But so it says the graph shows the approximate number of eggs Jameson collects over a couple of days. I want you guys to go back to your breakout rooms really quickly, which should only be like 2 or 3 people. So you should just be like having a conversation with 1 or 2 other people and talk about what does 4.5 mean in this situation. Is that 4.5 days for every egg, or is it 4.5 eggs for every day? Ooh, I gotta assign a couple of you guys. Again, you guys don't have to come back if you're still talking with each other. I just really wanted to, only give you a couple minutes to chat. Three, two, one, and now everyone should be getting kicked back in here. Who can tell us what this means? Let's go with Isis. Isis, what's this graph actually mean?
It means that Jameson collects about 4 to 5 eggs per day.
Yeah. So let's try to put a version of this in our notes. So guys, here's the biggest thing I want to remind us of. The X axis is the horizontal axis? I don't know why people keep getting kicked out of the call. Trying. So the x value is the first number. So in this case, that is the number of days. Because if you look at how the axis is labeled, it says days. So a lot of people say the y value first. And when we talk about unit rates, we normally say the y value first, which in this case is our 4.5 eggs. So, and now, he doesn't actually collect half an egg, but we're saying 4.5 eggs for each day. So we normally talk about y per x. So if you have a highlighter, you could get this all highlighted. Try to draw at least some version of this in your notes. Now, what am I missing on my axes? Yeah, I have no numbers on my axes. So what we want to see, now I am on graph paper, so we could count lines, but it's probably kind of hard to see. Check and chat. You're good, Lulu. So this would be 1 day, and then as long as I put a 1 right here, we know that we can count up. But if I count up, that is at 4.5. So remember, the y-axis is your vertical. And normally when we talk about unit rates, you can write this down if you want. I'm going to make this little note right here. I'm not going to say normally. I'm going to say often. Because normally is a pretty strong word. Often means like more than 50% of the time, right? Unit rates are often y per x. Like when we're talking about graphs. Unit rates are often y per x. You can say it the other way around. We just normally don't call that a unit rate. So what we're talking about here is like miles per hour. Or like eggs per day. Can you guys give me any other examples of things that might be unit rates? Just shout them out. What might be a unit rate? I should just zoom back out is what I should do. Is that better?
Yeah.
So I got another graph to show you guys. So if you don't have Schoology open, you might want to open Schoology and go pull up our slides. Because it's probably easier to see if you just look at it on your computer. I'm going to put you guys back in your breakout room in a second. Does anyone have questions about anything I've written right here? I wanted to give you guys a minute to draw this because I drew it while you guys were in your rooms. No questions about this? You'd be ready to talk to each other about a question like this? Alright, so I'm going to show you guys the next slide. Then I'm going to open the rooms. When you're ready to go to the room and talk about it, go there. Even if you don't have Schoology open, you can probably see enough from this to move on. So I'm going to leave my notes up. There we go. So now our question is, what does this point mean in this situation? The point 116, and more specifically, what does 16 mean? Because then we can talk about, okay, one of the other thing. But based off the labels on this graph, what does that point tell us? When you're ready to go discuss it, yeah, we'll use the same rooms. Madeline, what room were you in? Do you remember? 2. All right. I have to reassign you when you get booted from the meeting. I should just tell you guys to wait out the 60 seconds.
Yeah.
Like, because you don't have to come back when it says you can.
That's true.
And 5, 4, 3, 2, 1. Everyone's back. Well, they will be in a second. All right, so who wants to volunteer to tell us what this means, or I pick people at random? Mia, what do you think? What's this mean?
I think it is, 16 hours to knit a scarf.
16 hours to knit a scarf? You are absolutely right. If we look at the label on the x-axis for our first number, that's scarves, right? One scarf. So let's say this is like your grandma or maybe you are knitting scarves for somebody for like holiday gifts, right? And you're like, I'm going to knit everybody a scarf. And it takes you 16 hours to complete your first scarf. You can then think like, well, okay, if it's 16 hours per scarf and I'm making 4 scarves, how long would it take you to make 4 scarves? Well, what is 16 times 4?
64.
Yeah, there we go. Some tough math here on this Wednesday morning. So we can then make an equation from this, right? Can anyone tell me, and we don't have to use X and Y yet, we will in a second, but if we want to write an equation to represent this, we could say the time it takes, right? The time it takes. Actually, we should not. We often use big T for temperature. If we want to say the hours it takes, if we want to use a big H instead of a big T, the hours it takes is what? What should H be equal to? 16 times what?
4.
Yeah, or just like S, right? The number of scarves that we're going to make. So what this equation actually is Y equals 16X. And guys, please write this down. This is where our constant of proportionality, now we call it an easier name, and we just start calling it the unit rate. The other unit rate is the reciprocal, though. So, wait, 16, the reciprocal of 16 is 1/16. What is that unit rate? What does that tell us? What is 1/16? I can do 1/16. It takes me 1/16. What is that? Can anyone help me? If the other unit rate is the reciprocal, so if this is 16 hours, this one would actually get 1 hour. Because remember, it flips the order around. Instead of hours per scarf, oh, this would be scarf per, not pre, per. So if the first unit rate, guys, was hours per scarf, that first unit rate that we looked at, the other unit rate, the reciprocal unit rate, turns the label around. And guys, this is the trap door. If you're getting wrong answers to your work on Khan Academy, it's probably because you're typing in the reciprocal of the correct answer. I'm trying to tell you guys what I know you're going to probably goof up, because a lot of people do. Let's try another one of these. Back to your breakout rooms when you're ready. This question is asking us 2 different questions. How many cups of popcorn does Harlan use per cup of cereal? Please read carefully on this one. And then part B, we'll call this part A and part B. How many cups of cereal does Harlan use per 1 cup of popcorn? This is asking for both unit rates here, so be careful. Hey, let's make a new suggestion. When it says you can come back from the breakout room, don't. Just wait until it forces you back, so then we all come back at the same time. Unless you have a question, and then come back early and ask your question. All right, go chat about this. What are both unit rates here? And what do they mean? Do you guys just come in here and sit quietly?
No.
Well, somebody should be talking then.
I'm trying to figure it out.
Do you guys have Schoology open?
I do. I do.
Remember, Ooh, I might need to change that setting. Alright, you guys should be able to screen share again. I might go back out and tell that to everybody.
I think it just will be reversed.
Sorry, Mia, you don't need to unmute. I think you muted right as I was about to mute you. Who wants to talk about this? Volunteers? Or else I'm picking at random. Ooh, Sydney? Actually raising the Zoom hand. Go ahead.
I think, how many cups of popcorn? I think the first question is 2 cups.
How'd you figure that out?
So I looked at the graph, and the cereal cup lies above 1 cup, so I figured out that there's 2 cups per a cup of cereal.
Yeah, absolutely. So guys, if you are able to, please, you don't have to use a ruler and make perfectly straight lines, but throw a version of this in your notes, and you should be using graph paper. So that's why I'm using nice numbers in these graphs, is label your y-axis with popcorn, label your x-axis with cereal, and put this point here. But that point is actually 1, 2. Because this is 1, the x value is 1, and the y value is 2. Now, your graph doesn't have to be as big as mine, but there's other points along this line that we can find. So when x is 2, when x is 3, when x is 4. So if I look at when x is 4, and I ask myself how much popcorn, well, guys, if I use 4 cups of cereal, how many cups of popcorn am I going to use? I use 4 cups of cereal, how many cups of popcorn would I use?
2.
Wait, I may have just said that backwards. If I use 4 cups of cereal, right, on my x-axis, if this is 4, how many cups of popcorn will I use?
8.
8. Because our popcorn amount, right, we could say popcorn is 2 times the cereal, right? And this is the equation of our line, guys. This is y equals 2 times x. Please write that down. This is a great example. This line, this whole problem, this situation. But then part B asked us how many cups of cereal does Harlan use per 1 cup of popcorn? So now we're looking at 1 cup of popcorn. Right, 1 cup of popcorn would be like right here. Can anyone volunteer to tell me what that is? How many cups of cereal do we need?
Would it be half a cup?
Yeah! So our other unit rate, the reciprocal unit rate, says that my cereal amount, so I'm going to write this down here, cereal is half of the amount that popcorn is. If popcorn is 1, I only use half a cup of cereal. So these are the 2 different equations that we could write, but notice that cereal is our x value. So this equation would be x equals half of y, and that's not how we normally talk about lines. We normally talk about lines saying y equals. So I wanted to make sure that we talked about the fact that both of these are unit rates. Both of them can be used. And guys, you might have some siblings or some parents who like try to help you out and they argue with you about things. But like part 2 here, that's a unit rate and the answer is 1/2 because we use half a cup or half the amount of popcorn because it changes, but we always use half the amount of popcorn. So cereal equals half the amount of the popcorn. All right, so are we ready for another one? Stepping up the difficulty. Let's try this. So Toko has 30 tokens to spend at an arcade. Our 3 lines represent the cost of playing the 3 favorite video games for various numbers of times. So cost, sorry, I cut the C off up here. Cost in tokens is our Y, and times that you play it is our X. So hop into your breakout rooms and discuss which video game can you play the most. What does it say? Which game can Satoko play the most number of times with how many tokens does she have?
30.
30, right? We got 30 tokens. So which game can she play the most amount of times? Guys, I'm only going to give you like a minute or so to talk about this, but I want you to like be able to chat with each other to be comfortable about it. So remember, if you don't have Schoology open, it would be helpful if you did. Go ahead and chat about this. Lulu, do you remember what room you were in? Probably 5.
Stella and Tyler.
I couldn't hear what you said, but I'm going to put you in room 5. People get back here. So 30 tokens we should be able to find on this graph. So if we look at this, I'm going to shift the graph a little bit actually. so we can see it a bit easier. All right, we should all be coming back now. Anyone want to tell us which game we can play the most for 30 tokens? I'm looking for new hands. Madeline?
The KOF.
What made you think that?
Because it went like farther, but with less money.
Yeah, so guys, check it out. If we look at the cost axis, always look at which axis goes to which value. If we look at the cost axis, 30 tokens is this line right across the top. So the claw machine, we can play a little over 7 times. We can't actually play an 8th time. So who knows what the claw machine costs. But we can only play it 7 times if I drop down to my x-axis. DDR, I'm surprised they were allowed to say DDR here. But Dance Dance Revolution, right, we could play that 10 times. So it must cost 3 tokens per play. But KOF would be out here somewhere, right? KOF would keep extending out this direction. So these are the next sort of problems that you're going to see in Con, where it's actually comparing lines with each other. Okay, so I wanted to make sure that we looked at a couple of these this week before, like, this homework is due. So realize that the notes that we've been taking, if you set up the equation like y equals some number x, this number gets bigger as the line gets steeper. So if this line was steeper, if I wanted to change my mix of trail mix and I used a different line, this would have a steeper slope. So actually I should draw that in red. That line would use twice as much popcorn as the black line. So this red line would actually be y equals, more than twice as much. That's y equals 5x. And this is where we're going to pick things up, really more so next week when we're back in person, and we can graph lines together in person on graph paper using rulers. But if we do one more problem to wrap us up, and we look at who eats the most hot dogs in the same amount of time, or who eats the slowest, we can compare their slopes, right? So this asks who eats the slowest. Actually, I'm going to move this real quick so I can show my notes again. There's pretty good. So our slowest person in hot dogs per minute would be K. It's the lowest line, the lowest slope. Our fastest person be the highest line or the highest slope of L. And I guess the last thing I should probably leave you with here is our slope. Now this is not slope. The y equals, remember this is not slope, because it has to be in the y equals form. Y equals. But slope, if we want to start talking about slope, is the y per x. So in this situation, it's the hot dogs. This is kind of gross if you don't like hot dogs. It's the hot dogs per minute is our slope in this final situation that we're talking about. So now that I've made you all hungry for hot dogs, and now that you're going to go eat 30 hot dogs in like 5 minutes, right? Don't do that. That's a bad idea. Unless you have any questions that you want to hang out and chat with me about, please get mastered. We have AO and extensions today. I'm going to be AOing and extensionsing, if that is the proper way to say that, from school. So if there's any issues with Zoom or whatever, just wait. Like, wait in my waiting room or wait for me to start the call. I promise I will get it sorted out as soon as possible. But yeah, hang out if you have any questions. Reminder to everybody, if you have any Zoom issues or get booted off the call, I am recording this. Remember the little red frame here? I'm recording this, so it goes on YouTube. Go check that later. It takes about an hour for it to upload, but if you missed any parts of class and if anything is confusing to you, please go check the video, watch through that, reach out to me if you want some help. Aside from that, unless you have any questions, have a great day, guys. We'll see you in person next week.
Thank you.
Thank you, guys.